Example 21, a nozzle that discharges a 100 mm diameter water jet into the air is on the right end of a horizontal 250 mm diameter pipe. In the pipe, the water has a velocity of 3.6 meters per second and a gauge pressure of 415 kilopascals. Find the magnitude and direction of the resultant axial force the water exerts on the nozzle and the head loss in the nozzle. So let's draw the nozzle. This is the information: 250 mm diameter, the jet 100 mm diameter. So there's no pressure at 2 exposed to the atmosphere. At 1, the pressure is 415 kilopascals. So summation forces along x equals Q rho quantity V2x minus V1x. So the equation would be, this R here is the force that will hold the nozzle in place so that it will not be held in place. Then the resultant axial force the water exerts on the nozzle would be equal and opposite to this if R is positive. So the equation would be F1 minus R equals Q rho quantity V2x minus V1x, where F1 equals pressure at section 1 times area 1. So 415 times pi 0.125 square times 1,000 to convert it to newtons. So 20,371 newtons. Then Q times rho is pi 0.125 square times 3.6, then times 1,000 kilogram per cubic meter. So it is 176.7 kilogram per second. Substitute into this equation. By the way, let's solve for V2x or V2 by continuity equation. 250 square times 3.6 equals 100 mm square diameter times V2. So V sub 2 is 22.5 meters per second. And substitute now. 20,371 minus R equals 176.7 times 22.5 minus 3.6. So R can now be solved. It is positive leftward as shown in the figure. Therefore, the magnitude and direction of the resultant axial force the water exerts on the nozzle will be equal and opposite to this. So our answer is 17,031 newtons rightward for the nozzle. Then for head loss, we write energy equation between points 1 and 2. Datum through 1 and 2, elevation heads would be 0 because the elevation head at 1 and 2 would be 0. So we have velocity head at 1, 3.6 square over 19.62, pressure head 415 over 9.81, elevation head 0 equals 22.5 square over 19.62 plus pressure head 0, elevation head 0, then head loss of the nozzle. So calculating head loss in the nozzle, it is equal to 17.16 meters.